Hello, everyone. Welcome to today's live broadcast, Potency, Pesticides, and Metals, Oh My, Achieving Superior Cannabis Analyses with Simple Sample Prep Tools. I'm Laura Bush, the Editorial Director of Spectroscopy, and I'll be your moderator for today's event. We're pleased to bring you this webcast presented by Spectroscopy and Cannabis Science and Technology, and sponsored by CEM Corporation. CEM is a science-based technology company dedicated to bringing new, innovative systems to the laboratory marketplace that provide improved speed and simplicity. Last year, CEM invested over $12 million in research and product development in pursuit of these efforts. Before we get started today, we have a few housekeeping announcements. First, the webcast is designed to be interactive, and we encourage you to ask questions during the event. You can submit your questions at any time in the Q&A box, which you can find on the right-hand side of your screen. You can enlarge the slide window by clicking on the small square icon in the upper right-hand corner of your slide window, or by hovering your mouse over the lower right-hand corner and dragging the window to the desired size. The slides will advance automatically during the webcast. And if you have any technical problems viewing or hearing the presentation today, please click on the question mark Help widget in the dock at the bottom of your window. I would now like to introduce today's speakers. We are very pleased to be joined today by Dr. Alicia Douglas-Dell and Bob Lockerman. Dr. Alicia Douglas-Dell has worked with CEM for the past 11 years. After completing her graduate degree, she worked as a purification chemist before moving to the Molecular Sample Preparation Division. Alicia has been working on the EDGE product since its inception. She is very involved in the cannabis industry and sits on multiple committees that are working toward developing regulations for potency and pesticide analysis in cannabis and hemp products. Bob Lockerman is the Global Product Manager for the Analytical Division of CEM Corporation. With more than 30 years of experience with CEM, Bob has been instrumental in the development of microwave digestion products and applications in the areas of food safety, environmental, pharmaceutical, and cannabis analysis, and many others. Bob sits on the AOAC Subcommittee for Cannabis Regulation and works closely with cannabis labs to devise solutions for all their digestion needs. Thank you both for joining us today. Alicia, please go ahead and get us started.
Thank you, Laura, for that kind introduction. As evident from the title of the talk, you can see that we're going to talk about cannabis today. But specifically, we're going to talk about sample preparation. If you take anything away from this talk, I hope you see that CEM is offering you a simple, efficient, and rapid methods for sample preparation in this challenging industry of the world of cannabis. So with that, let's talk about cannabis in the United States here today. This map is taken directly from our website. It is a very handy tool where you can click on your state and it will pop up the regulations for that state. With this very ever-changing world, I think Illinois just recently came on as recreational legal, and New Jersey will be voting later on in the year. You need to stay on top of what's going on in each state. And since cannabis is not legal on the federal level, it is regulated on a state-by-state basis. Now, I am in a very unique position in the fact that the state that I am presenting from here today is North Carolina, and that is a gray state. So cannabis is not legal on either the medical or the recreational level at all. So I cannot be working with these samples in my lab. That put us in a unique position where we had to start working with collaborators and current customers to be able to get cannabis data. And I have to say, I have been so pleased with the cannabis industry because I think this is new to all of us. We're all learning. It's a little bit of the Wild West right now, and it's really nice to see everybody so eager to talk with everybody and just to learn, to make sure we have the best practices. So you'll see me thank a lot of people in today's presentation because it was more of an effort beyond CEM itself to be able to get this data here for you today. So if you go and look at any cannabis testing lab, they're pretty much going to offer services for potency, pesticides, metals, mycotoxins, terpenes, residual solvents, microbiological screening. So these are the tests that are usually out there that are offered. I'm going to focus today, or both Bob and I apologize, on potency, pesticides, and metals. And I really believe that those top three are the big hot topics. If you need to be doing anything, you certainly need to be focusing on those three. I specifically am going to cover pesticides and potency, and then I'll pass it over to Bob, who's going to cover the metals side of things. So with that, I'd be remiss if I didn't talk a little bit about hemp. In this world, our definitions are actually changing as well, right? Whether we're saying cannabis or medical marijuana or hemp, we all actually are referring to that same plant. Hemp is cannabis. It's just a low THC cannabis. And again, this ever-changing world, back in 2018, the Farm Bill legalized hemp. So that changed the path of a lot of what we were looking at. All of a sudden, I don't know about everybody listening, but I certainly know within the region that I live, if I drive out on the roads, I am seeing hemp and CBD on every corner. It is blowing up right now. This is a hot topic. And so it's interesting because now we're talking on a national level where hemp is legal, so everybody's interested in this topic. And since it is the same plant, you're going to treat it in the same way. So whether you're working with hemp or cannabis, you're going to be following those same methods, and you need to be meeting regulations. So testing is indeed very important. At CEM, we offer two products to help with the sample preparation in this industry. We have our EDGE product, which is what I will be focusing on, which is good for potency, pesticides, mycotoxins, and terpenes. And then we have our Mars 6 product, which you would use for the metals. Now, these two areas are very different in the fact that the potency, pesticides, mycotoxins, and terpenes are more on the organic side of things. You're going to extract those with organic solvents, where on the metal side of things, you use acid. And typically, it's not a good idea to mix organics and acids. So you really don't want to be using the same instrument for both. Furthermore, the metals requires a significant amount of temperature, where temperature at high temperatures can be detrimental for a lot of the other methods such as potency and pesticides. So with low temperature control and not mixing organics and acids, we really believe that the solution to the cannabis sample prep comes in these two instruments, both the EDGE and the Mars 6. So I'm going to take a little bit of a step back now and talk about sample preparation as a whole. So really any sample preparation for any industry, any sample. And this pie graph that you see there was taken from LCGC magazine a few years ago. And it is staggering to see that 62% of our time is still spent on sample preparation. In the modern world, we have come so far in the world of analysis with our UPLCs and our high-resolution mass specs. Analysis has really come a long way. But sample preparation, it really just hasn't gone into that modern world. We're still, if you walk into the sample preparation lab, you're going to see a bunch of glassware. It's going to look dated. It just hasn't come up as far as all the other processes have. And so our goal at CEM is to solve that problem, to make sample preparation modern, to make it simple and rapid and efficient. Now, the list of sample preparation techniques that I have here are certainly not exhaustive. There are so many different techniques that you can be running out there. But I try to think of a few that you may be considering if you're working in the cannabis industry. And I am not going to spend time going over every one of these techniques. All I really want to note is that as a whole, they really are time-consuming. They use large amounts of reagents. They're costly, and there's tedious sample preparation required. And we believe that with the Mars 6 and the EDGE, we have eliminated these limitations for sample preparation. So I am going to focus, as I mentioned, on the organic side of things. I am going to talk about potency and pesticides and focus on our EDGE product. So next slide is going to be a video. We are having a little bit of a technical difficulty with those running in Chrome. So if you see a black screen with a play button, please go ahead and click that play button, and then you should be able to see that video, no problem. So this video is going to walk you through the edge. This is running in real time. So throughout this video, this is as fast as the edge can run. The first thing you're going to do is put in your Q disc, which enables your filtration, and then assemble your Q cup. Your Q cup is very light and go directly to the analytical balance, and then you'd weigh your sample in. The racks that hold our samples are easily removable, so you can be preparing samples while others are running. Once you load your rack with your samples and your collection vials into the system, you simply choose your method and then hit play, and you can walk away. It is a system that runs in series, so it's going to run 12 samples, one right after the other. So you see it loading the first sample here. It's going to take that sample and it's going to load it into our extraction chamber. Once it's in the extraction chamber, the pressure seal is going to come down and create a pressurized environment. Once you have that pressurized environment, we're going to add solvent via both the bottom and the top. That solvent on the bottom actually creates a gap of solvent on the outside of the Q cup. As we start to heat and pressurize this chamber, that solvent on the outside disperses up through the filtration disc, through the sample, allowing for efficient extraction. Once we've reached temperature and our hold time, our sample then is going to drain through our Q disc, filtering it through a cooling coil, so that if you're at high temperatures, you're now going to have a room temperature extract, and into our collection vial. Then we add our rinse. Our rinse is just clean solvent that comes through the sample and is also collected in the collection vial, as you see here, so that we make sure we've rinsed everything out, we get good recovery. At this point, your extraction is done. You could be taking that extraction going over to analysis. However, we realize that when you run in series, we need to be cognitive good washing. So the entire fluidic pathway that saw a sample, we want to make sure that we wash that entire pathway. So now you're going to see the edge go to our waste port and do that wash. You have complete control over the washing parameters. You can mimic a method itself so that you can ensure that you are going to have good washing and no carryover. So once the edge is completed, it would then move on to the next sample, or you would have a completed rack. You'll see Brittany come here, grab that rack, and she could go head over to analysis. One of the feel-good things for me is that extracted sample, if you take it and you look at it, it is completely dry. So that sample just moments ago was in solvent, and now it's bone dry. That just tells you, okay, we got everything, we've covered everything, and then you've got your extract that you can go directly to analysis. So now that I've introduced you to the edge, you have a visual. You know what's going on here, and so let's talk about it in even more detail throughout the rest of this talk. But let's take a little bit and look at cannabis. So it is a complicated plant. Just the plant itself is complicated. It's very waxy. It's difficult to deal with. But then if you take it, if you can think about it, that product exists now, right? We've got this in oils and extracts, edibles, health and beauty products, the soil itself. This world is very broad. There are a lot of different types of samples that we're having to deal with, and that really complicates the problem. This is difficult. This is challenging. And what I'm offering here is that regardless of the sample type, we're going to treat it in the same manner on the edge. So whether you're working with a brownie or the cannabis plant, you're going to be able to prepare it and run it on the edge with one simple method. Now, when you have such a variety of different analytes you're looking for in different matrices, any method that is multi-matrix, multi-analyte is going to be appealing, right? And so when people look in this product, one of the methods that they tended to come to a little bit more than some of the others is the catcher's method. Now, I am not going to focus on all the details of catchers, but I just wanted to introduce it because it's probably one of the more commonly used methods for sample preparation with the cannabis plant. And I understand why, because it's multi-matrix, multi-analyte, so it's appealing. Catchers at the heart is a two-phase process. It is a salt partitioning extraction followed by dispersive SBE cleanup. Now, that salt partitioning extraction, that's an exothermic reaction. So it generates heat. And what we're learning in this cannabis industry is that heat is not our friend. And it can lead to degradation of some of the products and the pesticides that we're looking for. That's maybe not the most applicable method at this point simply because of the heat. But furthermore, if you look here, here's just this salt partition extraction. So you would then take an aliquot of this and then do cleanup to finish up the catcher's process. But the AOAC approved method for catchers calls for 10 to 15 grams of sample. What you have pictured here is 2 grams of sample. And you simply could not run 10 grams, nor would you want to run 10 grams of a cannabis sample. So even at the heart, you need to start adapting this method to this product. It tends to be really messy and difficult to work with on this platform, and we're able to avoid all of that with the Edge. So I want to focus a little bit more on the benefits of the Edge. It truly is simple setup. As we go through this presentation, I'm going to walk you through every step that you need to do. And I want to do that because I want to emphasize how simple it is. And I want you to be able to come back, refer to my slides, and be able to repeat this process. It is not complicated. And so that's a big bonus. Also, extraction time is very rapid in that it's going to be less than 10 minutes. We use minimal amounts of solvent. I mentioned a little bit about that precise control of temperature. So with that catcher's reaction and that exothermic reaction, you have no control. But here on the Edge, temperature is an option, not a requirement. And you could run at room temperature if you desired. So you have complete control, and you can control it at a very low temperature. And all of that leads to a very efficient extraction. So I told you I was going to give you all the details. So let's talk about how you would prepare your cell. Now, this sample preparation I'm talking about here, this would be the same regardless of whether you were looking for potency or pesticides, regardless of whether you were working with an edible or the plant itself. This is the way you would prepare it for all samples. The first thing you need to do is assemble the Q-cup. And I'm going to zoom in a little bit here because the filtration disc is a really crucial part. And we offer a wide variety of different Q-discs here at CEM, but I really feel that our G1, that is a glass fiber 0.3 micron filter, is the best for these types of applications. Now, you'll see in some of my other methods where some of our customers have used different filters, so you're don't have to run the G1. It's just my go-to disc. So when I present it, I really like to talk about the G1. Now, for anybody that is familiar with glass fiber, it is a little bit brittle. So while it's a great filter, in our system that is under high pressures, we need to take an extra measure where we're going to use that C9 disc, which is a cellulose disc, as kind of a support. So we create a sandwich of that G9 with those C9 discs. So that makes a very robust situation that's going to work for any matrix type and make sure that you get good filtration. Now, we offer these products at a very low cost of less than $1 for everything you have here per test. So it's really cost effective as well. So once you put your Q-disc sandwich at the bottom of the cap, you then screw that cap on. It is one thread, so it cannot be cross-threaded, so it's super simple. In a matter of seconds, your Q-cup is ready to then weigh in any sorbents if you desired. Now, that dispersive solid phase extraction cleanup step that you did in catchers, you can do something very similar on the Edge if you would like. So if you were using a cleanup step, go ahead and take that cleanup tube and just pour it directly into the Q-cup. We have tested pretty much all the products out there on the market, and our system is compatible with any of them. So whether you want a little bit of PSA or C18 in there, if you desired, you can add that to the Q-cup at this time. You would then weigh your sample into the Q-cup, and then if you were doing a spiking experiment, we'd recommend to spike and then let it stand for 30 minutes prior to extracting, just so you have your best foot forward for good practice and to get good recoveries. So now I want to talk a little bit about the samples we are going to talk about with the data here today. And I mentioned before, I'm in North Carolina. I can't run actual cannabis in our labs. So we have to get a little bit creative and set up partnerships here. So we work a lot with ResTech, and they had a customer, Convergence Laboratories, and so we put together this trip where we head out with ResTech to Convergence Laboratories and had an edge installed for a week, and were able to generate a lot of data. Now, I do have to say this is very preliminary data. This trip just happened a couple weeks ago. We're still digging through a lot of it, but I hope that what you see here today is very promising, and we're super excited about what more is going to come out from it. So I would tell you guys to pay attention to the CEM website, because we're going to be releasing more application notes here soon, very much from this data. So big thank you to ResTech and Convergence Laboratories, because most of the potency data that I'm going to present is possible because of them. So we worked with 3 different samples at Convergence Labs. We worked with a chocolate sample, a gummy sample, and then the plant itself. So I'll be showing data from these 3 types of samples. So again, a very wide variety. All these samples are going to behave differently, but we're going to take one method and apply it to all. So this is the method that we ran. And this is a screenshot taken directly from the Edge software. So this is what it would look like if you were actually programming the method. You have control over the solvent, over the volumes, over the temperature, and the hold time. You can also do multiple cycles. However, for any of the methods I'm presenting here today, only one cycle was necessary. Now, I mentioned this is a little bit preliminary data. We're still trying to dial in this method. So we were looking at some different temperatures and some different solvents. In the end, we found that IPA was the best solvent for potency under this environment. So I've got the IPA listed there, and then I'll show you some data from both 40 degrees C and 80 degrees C of the different temperatures we worked with. I also have our wash parameters listed here. As I mentioned, carryover is something you want to make sure is not happening. And so our go-to recommendation is to have 2 washes, to have one wash where you have a hold time and it's going to heat, and then another one where you don't heat and you don't hold. That tends to be the best washing parameters moving forward. So put those up there too, just to show you the control you have on the washing end of things as well. So once you've ran your method, you then have your extract. You do need to make sure for quantitative analysis that you know what volume you have. For all the data that I am presenting here today, we simply diluted up to a known volume and then went on to analysis. For some situations, it depends on your analytical equipment, you may need to dilute down to a known volume. So whether you're, concentrate down. So whether you're concentrating down to a known volume or diluting to a known volume, make sure you know your volume. There is going to be some inherent loss during that process. So you're going to need to make sure that you know exactly how much volume you have so that you have good analytical data. And we all know that good sample preparation leads to good data. So you want to make sure you're being thorough in that. Here is a chromatogram. Again, this was done out at Convergence Labs, so they shared this with me. We were using UV detection here, and you see that we see all the cannabinoids and we get good separation. So we're able to identify the cannabinoids and be able to see their presence. If we look at the data, I mentioned that we were going to look at 2 different degrees, 40 degrees C and 80 degrees C for running on isopropanol. And the take home here is to really see that across the board, we have very similar data for the different cannabinoids at the 2 different temperatures. But if you start to look at the reproducibility, it was more reproducible at 40 degrees C than it was at 80 degrees C. So, that kind of shows you that need for higher temperature, it's really not there for, in this case, the potency that we're looking for. And so why run at those higher temperatures when you can control it at lower temperatures and you can get more consistent, better results for these cannabinoids? And just to clarify, this was in the flower itself here is the sample matrix that we were working with. When it all comes down to, you want to know your total THC present, right? That's probably the biggest factor that everybody needs to know. And when we were working with Convergence Laboratories, the chemist there said, I think our hand method might be reaching saturation. And this is before we ever did anything on the edge. So interestingly enough, when we ran it on the edge, we still got consistent values, but we got consistently higher values, indicating that they were probably correct in the fact that they were indeed reaching saturation with their hand method. And obviously, we want to make sure we have accurate numbers of THC here, and I think a lot of people are looking for those higher values as well. So having a method that you can depend on to give you accurate results is really an advantage. So I mentioned we have, we're working with a lot of different people. Up till now, we've talked about the data coming out of Convergence Laboratories and that collaboration with ResTech. But we have a customer, Express Toxicology Services, that was also willing to share their method and their data with me. So a huge thank you to them as well. And in this case, their method was a little bit different. So again, you've got some control. You can dial your method in for your samples and your environment. In this case, they found methanol was working the best for them, and they actually are running at a higher degree. They're running at 90 degrees C. It's up to the customer to make sure that they've got the method that they're happiest with. We saw a very similar story here at Express Toxicology in that when they took the edge method and they compared it to the hand method, they were able to get higher recoveries for the edge method than they were with their hand method. So they were very satisfied with this and got a really rapid and efficient method to be able to get this data out. So now going back to Convergence Laboratories and talking a little bit about those edibles. So I mentioned that we were going to run gummies and chocolate. And in this case, we compared it against the catcher's method that they would typically run for this. And what we see, again, is comparable results. So regardless of whether we were looking at the gummies or the chocolate, we were able to achieve comparable results with the edge. And that was the story at Convergence Lab. So I'm just talking about the potency and the cannabinoids here today, but we ran potency, pesticides, and mycotoxins while we were out there. And for everything we ran, we got comparable or better results. So they were very pleased with all of that. And we talked a little bit about that catcher's method and the complexities and just the inherent fact that it is a manual method. So here we're giving the option of automation with the edge, and we're able to achieve equivalent results. So again, all this data, thank you to these people that were able to provide it to me. But we want to be able to run it in our labs too, right? So we can't run cannabis, so we started with hops. And as we were talking to our customers, it was validating, and then they also often use hops as a representative matrix as well. So we started initially working with hops and spiking and making sure we got proof of concept that we can get good recovery. And if you want to go on to our website, we have application notes out for our hops data. We also worked with oregano, which is another representative matrix. So you can see all of that data, all the recoveries and RSD values will be in those application notes. But our world changed when the Farm Bill passed and we were able to start working with hemp. So now we can actually be working with hemp products in our labs. And we connected with a local hemp farmer, Brad Todd, and he has been not only educating us about this business, but really providing us samples as well. So that's been a great relationship, and I really look forward to what that relationship will be in the future as well. So these are ongoing experiments now where we are working with hemp in our lab. So again, I'm excited on where we're going to be able to do working with those products. So this is going to conclude me talking about potency, and now I'm going to move into talking about pesticides, and then I'll pass it over to Bob. So pesticides, again, another big topic, and they're everywhere. If you just look at these pictures here, you just see, we all know that these are out in our environment. And honestly, pesticides get a little bit of a bad rap. To be honest, they do a lot of good too. But they're present, and in this world of cannabis, we're having to regulate them at very, very low levels. So we need to make sure that we are doing very good testing in this sector. Here is the EDGE method for pesticides. It is very similar to the potency method. One of the big differences is we do use a different solvent. So acetonitrile with 1% acetic acid is the most commonly used solvent for pesticides, and so that works really well on the EDGE. And again, we're going to keep that temperature really low, specifically for those pesticides. They start to degrade at higher temperatures, and you really need to keep that temperature low to get good recoveries. Up to this point, I really have not talked much about cleanup other than it's an option. I like to put this picture out there, though, because it shows you what cleanup can do. Here you see on the left where we did not use cleanup, and you see that layer of lipids there on the bottom. And then when we did use cleanup, you see that layer is no longer there. So the cleanup, it's doing something, right? It's cleaning up what it's supposed to be. But I would caution you with cleanup in the fact that sometimes it holds on to some of the analytes that you will be looking for as well. And you don't want to be losing analytes. So it really comes down to your analytical equipment and the analyte site that you're looking for to choose the best cleanup for you. In some of the methods we've been showing, data we're showing here, cleanup was used, and then others, cleanup was not used. So just want you to know that it's an option, and if you have any further questions regarding what type of cleanup to use, CEM would gladly have a conversation with you and help you with that. I mentioned before, you need to prepare for analysis. You need to make sure that you have a known volume. So on the left there, you see the bright green extract. So that is our cannabis extract. And for the world of pesticides, they are both, some are GC amenable, some are LC amenable. This was taken out of our the data that was done over at Convergence Laboratories. And what they found for their analytical equipment is that going into the LC, they did not have to do any cleanup. But when they went to the GC, they did do some cleanup. So they actually did a little bit of cleanup for the GC samples, and then they went direct to analysis for the LC samples. The data that I'm presenting here today was shared for us, and they were using whatever equipment they had in their lab. But again, for me, to keep me honest, I like to at least show you an analytical method that is applicable to the topic that we're talking about. And so what we have in our lab is the Waters Acuity H class with a Zevo TQD. So any data that is coming out of our lab was run on this system, and this is a very standard method that we use here. So again, just want to keep me honest, make sure I'm presenting everything I can to you. And in the same rule of thought, I like to show you the chromatogram as well. Now, when we saw the chromatogram of the cannabinoids, that was UV detection. So separation was really important there to make sure we could identify each peak. In this case, we're looking at MRM transitions. So we really want to make sure that we've got good peak shape so we get good data back for the specific pesticides. Now, this is a very simplified chromatogram because obviously in the world of pesticides, we are looking at hundreds of them. And so just for representative purposes here, just pulled out a few pesticides to show you the peaks of. So again, I'm going to thank yet another customer. So in this case, it's going to be the Washington State Department of Agricultural, Chemical, and Hop Laboratory that did this study for the pesticides for us. And what I have represented here is just the Colorado list, okay? So, but over 300 pesticides was run for this study. Again, we have an application note here, so if you want to go onto our website, you can get more data on more extensive pesticides that were run. I like to be able to see the data, so I like to have really one nice concise chart where we're talking just specifically the Colorado list, and we can see good recoveries for the pesticides that we were looking for here. So that pretty much concludes my talk. I hope you've seen that the EDGE is a good option for potency, the EDGE is a good option for pesticides, but furthermore it can be used for those mycotoxins and terpenes as well. So with one instrument, you get a fast and simple sample preparation that is automated, that can be used for all these difficult sample types for cannabis and for these different analyte sectors that we're looking for. So with that, I am going to pass it over to my colleague, Bob Lockerman, and have him get you all excited about what we can do in the world of metals. Thank you, Bob.
Well, thank you, Alicia. I really appreciate that, and certainly a fine presentation on your portion of the world of the organic side of things. I'd like to move us on to talk about the metals side. or the inorganics, which actually is much easier in my opinion. For metals, we just need to completely destroy the organic matrix in order to look for the analytes of interest, the heavy metals. We do not have to worry about getting too hot because you cannot overdigest samples. And we mainly care just about 4 analytes, some others, but primarily 4, rather than hundreds that Alicia's team looks at on the organic side. And we will discuss these metals of interest as we go forward in the various sample types like we see here. And again, we work pretty much with the same matrices as Alicia does, and in some areas we actually even deal with the preparation of water as far as the irrigation of the crops and whatnot. So again, we're looking for the metals, which are the toxicity, and rather than the different pesticides or potency and things that we were talked about before. So why do we have to digest samples? Let's take this back a step. And why do we have to digest samples? Well, we have to get it to an aqueous solution. Before we can nebulize it and get it up into the ICP or the ICP-MS spec, we've got to get it into a form that the analyzer can actually accept, and that is an aqueous solution. Now, microdigestion is we think is a very good way to achieve this because we use pressurized vessels. We actually heat vessels and keep them sealed so they pressurize. And that allows us to get to higher temperatures above the boiling point. So nitric acid at 200 degrees is certainly has a much more oxidative potential than it would, say, at 120 on a hot plate. And we take advantage of that for the fact that we then can get a much better digest and we can only use nitric acid. We can use any acid, but we typically use only nitric acid, which is very clean acid typically, nice to work with. And it'll work for pretty much all sample types. And this also speeds the decomposition process to the point that you can run a batch of samples and be ready to go to the analyzer in about an hour once you put it in the system. And microdigestion allows for the rapid heat up and cool down of your samples and really becomes the highest throughput, which is really important because cannabis labs tend to have a lot of throughput in there. They're very busy laboratories. So what's our option? What are we offering here for metals in cannabis? And what we're offering here is the Mars 6. A batch microdigestion system that, depending upon the type of vessel you use, will prepare up to 40 samples per batch. A lot of what we do in the cannabis industry is using our Express Plus, which is 24 samples per batch, and that allows us to go with a higher sample size, which is nice for certain states that have certain requirements for the amount of sample that you need, California being one of them. There is a pre-programmed cannabis method on board the system, so that means you don't have to do method development, and this one method will work for all those sample types. And I'll be talking about it later, but it also means you can run all those sample types in a single batch, which is it helps with the productivity. The system also has on that touch screen onboard instructional videos that talk about sample prep techniques, how to assemble vessels in case somebody forgot how to if you have new people come in. So it's really nice to have everything in one place, and we find that this is a very easy instrument to use out there. Then the heart of the system is actually, we call it the vessels. And these vessels basically need to be constructed of materials that will hold high enough temperatures and pressures. So they're constructed of Teflon with a Kevlar sleeve. But notice how simple. There's only 3 parts to put together. You've got your liner, the tall piece up there, a little plug seal, and a cap. And that slides into that Kevlar sleeve. And that Kevlar sleeve just provides the strength so that the vessels can hold the temperatures and pressures required to do the complete digestion. And this has turned out to be the perfect vessel for plant materials, oils, extract, lotions, the soils, the water, and anything that you need to run. This vessel can run it. And it can run it in a single batch, so you can mix and match. And again, that's what really leads to the productivity. There's also an optional disposable glass liner you see in the bottom there. And that is actually, it provides a convenient option to work in because they are disposable and it eliminates vessel washing. So you can weigh into that glass liner and then add your acid and slide it in. However, as a caveat, glass is not as clean as Teflon, so it's important to understand the blank values of our glass as it relates to your detection limits. And we've done a big blank study, and all of those blank values can be found on the CEM webpage. Again, as we were saying, the CEM webpage is a very good tool, a very good resource for this industry. So we mentioned, I said there's one, this is a digestion method. You don't need to worry about what's on the left there. We summarize it for the right. And basically what we're saying is that you can have one digestion method, and that will cover all your sample types. In this case, we used the Mars 6. and we, with Express Plus vessels, 1/2 gram of samples, mixed and matched, 10 mils of nitric acid, and I'll be going over in a minute what these samples were. We do a pre-digest, and that allows the samples to regulate, so to speak, if there's any sugars or whatever materials that might want to digest very easily without any heat, we let those go first, and that kind of normalizes the batch. And after we pre-digest, we cap them up, and we put them in the system, and we ran the cannabis program. But what the cannabis program is, it's a ramp for 20 minutes to 200 degrees C with a 10-minute hold, and then about a 15-minute cool down if you want it, basically before you can pull them back out. Now, as Alicia mentioned, we're a gray state, so we can't be running cannabis in our lab. This work was done even before the Farm Bill was passed, and all we were curious is if we got materials that were similar to the edibles and oils and things out there, could we get a clear digest if we mixed and matched the samples, as I mentioned, all together? And so this is quite a variety. We do gummy bears, mints, we did pretzels, chocolate, brownie brittle, some raisinets, chocolate raisins, coffee cake. Then we actually went out and got some hops because that was the closest at the time we could get to simulate the flour. And we did some peanut butter, beef jerky, some of the hop oil, and a granola bar. And again, those were all batched in a single system, run with that method that we used on cannabis, that we called cannabis. And when we were finished, we had a clean, clear solution and on all our samples, and that was really good. But with the Farm Bill going through, which was nice, we could actually step it up a notch, and that's kind of what we did here. Now, for the analysis, all your states, as Alicia mentioned, they all regulate because it's not a federally approved product. So every state sets its own regulations. The one common is that they all require the big four, and the big four are known as arsenic, cadmium, mercury, and lead. And why the big four? Why do we do this? These are the most toxic elements. These are the ones that you really have to be careful of. Some in the medicinal area actually do some additional elements, and they follow some USP methodologies, and that's fine. We've got a built-in USP method as well in the microwave digestion system, so if you want to follow that methodology, we can do that, and not an issue. And that just means you're adding additional elements to the list, and also your detection limits may change. The USP has lower regulations, but any event, we did all our work on an Agilent 5100 ICP OES and ran it in Axial, and you can kind of see the various conditions that we used. So we were actually able to do the analysis this time. And with that, we actually were able to get, as Alicia mentioned, we go down the street not very far, and there are big signs out there that say CBD. And we go in there, we can get both the CBD oil as well as many other products. So we were actually able to get some topical cream, banana fruit snack, some cannabis flour, which remember this is hemp flour basically. We were able to do CBD oils in 2 different concentrations. And again, all these were run together. They were spiked between 0.2 and 1 microgram per gram. And you can see the recoveries are quite good. Now, we did more samples than this, and as Alicia mentioned, we were trying to keep it for brevity. We show these, but we did more samples, and we actually did more elements, and that will be coming out on an application note by the end of the summer. So again, check back to the website because I think you're going to see that, I know you're going to see some additional information. This is the #1 thing that our laboratory team is working on right now because it's such a hot topic. So we are working both ourselves and then working with other manufacturers to attempt to get this information to you. I will admit, Alicia's team's done a much better job of collaborating. We got to start collaborating a bit more on our side, and we certainly will. And the local grower, Brad, is being real helpful to our group as well, so we really appreciate his assistance. So now we also did the total recoveries, and as you can see, those recoveries are very low. That's good. You don't want recoveries of these elements. If you're going to get a lot of these elements, you're going to be out of compliance. And just for reference of that, you can again see the arsenic, cadmium, mercury, lead. And then if you look down below that second chart, that is the action levels for the state of California medical. These actually are, as our chemist who did the work pointed out, they're higher limits than what you would see for typical USP requirements. But again, most states do not require the USP. So what we see here is your action levels are that 1.5 for the edible products for arsenic, so to speak. If you look down one below, the inhaled is much lower. And of course that makes sense. It's directly into your lungs, into your body. and then topical has the least medical action at 3. And so they always have action levels depending upon how the product is going to be used. So we were happy to see that obviously the products that we purchased were well in compliance with any regulations that the state would put out for these heavy metals. And again, we've got more data that will show up here in our website on an application note, and our target on that is the end of August. So again, it's good to be able to work with products that are more similar. So let me summarize the digestion side of the world then. And again, as you can tell, our side is a lot simpler, and therefore our presentation times are a lot shorter. The digestion summary is the Mars 6 yielded clear digestion of many or most all the ones that we did, cannabis, hemp products. I'm sure there's some out there that we'll have to do some checks on, but we really try to work on a wide variety of materials that would be higher in fat, that would be higher in sugars, that were crystalline form, all types of things, so that we were putting the system to the test. And it basically meant that we could do all those in a single batch using one vessel, which is nice. So we simplify the process for the fact that all cannabis sample types require just one system, one vessel type, one method, and can be batched together. And that is a real advantage out there. That really simplifies things, and that's one of our goals. We got to simplify this so that you can get to the analysis side. We offer the highest throughput, at least in terms of microdigestion, for the busy cannabis labs. You're going to be able to process samples faster than you are using any other method as far as sample preparation for metals analysis. We had great spike recoveries, as you could see, and the reproducibility of our unspiked, of our just samples, were extremely tight. So the analysis was good. In order to get analysis good like that, you have to have a good digestion in place. You have to destroy the organic matrix. That's really the key. The better you destroy the organic matrix with those higher temperatures, the less interferences you're going to have on your spectrometer, and therefore the better chance for good analysis. Kind of wrapping up a little bit, one thing that's important is the CEM, we've been out there for a while. We're closing in on 40 years. And so therefore we have a large number of people in the field, whether they're field specialists, technical sales representatives, or field service. So if you wanted to see some equipment in your laboratory, we can do that. We can bring that in and demonstrate. That's not a problem. All the reps have equipment that is available for demonstration, which is nice. And then also a lot of those docs are the field service people, which we hope you never have to see. But just in case you do, they're there. They're right near you. They're going to get there very quickly. And service offers actually 24-hour telephone support. So somebody's always on page if you have a problem in the middle of the night, so to speak. So we're there to support you. Finally, these are the teams that actually were working on this. The molecular team headed up by Alicia Stell, who of course just did the presentation, and my team. And we celebrated a lot of hard work. We stuck out of the lab for an afternoon, and we did an escape room, which was a lot of fun. We teamed up against each other. I'm sad to report that we lost. We did not get out. Well, they did eventually let us out. Alicia's team did get out, which was good for her. Barely, 5906, but anyway, we took our loss graciously, and then we went back to the lab and did some more work. So again, to wrap it up, it's cannabis sample prep, as Alicia said, made simple. Whether you're doing it on the organic side with the Edge or the metal side with the Mars 6, we think we've got a really good opportunity to make your life simpler, and we have two good products to meet the need. So with this is going to conclude the presentation portion of the webinar, and I will now turn everything back over to Laura, to you, for some question and answers and any other housekeeping items that are necessary. So thank you.
Thank you very much, Bob and Alicia, for that excellent presentation. It is indeed now time for the question and answer period. As a reminder, if you would like to submit a question, you can do that by typing it in the Q&A box, and you can find that on the right-hand side of your presentation window. All right, so let's get started. I see some questions coming in. So here's one to start with. Do you see issues with THC conversion with a heated extraction?
Thank you, Laura, for that question. Yes, so that conversion is going to happen if you are using high temperatures. So we have found, like I said in the presentation, that lower temperatures are best. So if you can stay at just 40 degrees C and still get good recoveries, then that is going to be your best practice. because we don't want that conversion to happen. We want to make sure that we are profiling the cannabinoids properly, including the isomers. So yes, temperature is a factor. That conversion will happen at the higher temperatures, and you want to make sure you are staying low enough such that conversion is not happening.
How do you run so many sample types together in one digestion batch?
Okay, I'll handle that one for me, the metal side, Laura, and that's a good question. And really it comes down to three basic things. It's the temperature you need to achieve, the digestion system itself and how it responds and how it controls, and then the vessels. So remember, you cannot overdigest your samples. So as long as we get to the hottest temperature for the most difficult sample matrix, and that's typically your oils and whatnot, we'll be able to get all of them into solution. Now, they're going to digest at different rates. So you actually need a system that has very accurate temperature readings on all the vessels. And that way the microwave can make continuous power adjustments so that the hot samples don't run away, so to speak. And if you do that, it allows them all to normalize in the hold. So during the ramp, they move at different rates. During the hold, they typically all normalize out to the same temperature or very close. Finally, you need a vessel robust enough to handle these conditions. And as we showed in the work we did, the Express and Express Plus vessel really meets this challenge.
Thank you. Can you use the same method for potency and pesticides?
Thank you, Laura. Again, that's a good question, and I'm actually seeing a lot as I look through the questions that people are putting up here that are dealing with this one in particular. So it kind of comes up to your discretion because you can at some extent. So I've talked to some customers that actually have a method that they are applying to their list of pesticides and potency, and they are happy with their results. So I do have some feedback saying, yes, I think this is possible. However, I have feedback on the other side of things as well. So I think it matters. Again, this world is so broad that the regulation is different in every state. And so if you're in a state that's requiring a very large group of pesticides, the reality is it's going to be your best practice to do separate methods. If you want to make sure that you are getting all of your pesticides and all of your cannabinoids where you've got to, you're separating out all of your isomers properly, I would recommend two methods. Now, on the edge, you can run them back to back. So you could run your pesticides method and then your potency method, one right after the other. So kind of like Bob was just talking about how you can mix samples for the digestion, you can mix samples on the edge as well. So it's not like you have to do all pesticides and then potency. There are 6 solvents plumbed into the edge, so you can have your acetonitrile, because it really comes down to the different solvents, for your pesticides, and then have your methanol and your isopropanol for the potency plumbed in. So it really does make it simple. So yeah, I mean, we're still learning. Like I said, I could kind of go both ways on this question. Got some people saying, yeah, it works for us. But I think if you've got a very long list of analytes you're looking at, that it's best to hone in that method specifically for the pesticides and then a specific method for the potency.
Very good. What is the maximum sample size you can digest in the Mars 6?
Okay, that is a good question as well. And again, that's going to depend on what you're trying to digest. It's pretty easy, and of course it depends on the vessel as well, but let's take the Express Plus. It's pretty easy to digest up to a gram of plant material. And actually there's some certain edibles, especially if they're high in moisture, that also can be digested at a gram. Basically, when we mix and match, we were using up to a half a gram. And that's because you, again, had samples that were higher in fat and then some that were higher in sugars. So when you do those sample sizes, especially though higher in fat, it's going to limit you to typically a half a gram a sample. So the nice thing is we can say is based on all the work that we did, we can certainly digest a half a gram of all the samples we've been working with so far. And that's good because, again, for certain states, you have those requirements. But so far, and then 1 gram of materials, again, if it's something easy or high in moisture, is also very possible. So I hope that kind of answers that question.
Here's another one. Can you run in-cell cleanup on your extractions?
Hello. Thank you, Laura. touched upon this a little bit in the talk. However, I certainly didn't get into details on it. But yes, you can run in-cell cleanup. And like I mentioned, you can use any product out there. We've tested products from Agilent to Sigma Aldrich to ResTech, pretty much all the companies out there that are selling catcher's kits. We've kind of taken that dispersive SVE tube and we've thrown it in there to make sure that is compatible with our system. But again, I caution you because sometimes the cleanup can hurt recoveries as well. And one of the nice things is you can put that whole catcher's tube into the edge if you want, into your Q cup if you really wanted to. However, you don't have, that's probably more than you would need. So for simplicity purposes, if you don't want to have to weigh anything out, go ahead. But I'd actually recommend buying what you need, which in most cases, maybe just a little bit of C18. You don't want to make it too complicated. And getting some bulk C18 and then just adding just a little bit, like a half a gram or less in there to do just a little bit of cleanup is probably the best practice here. But yes, of course, cleanup is possible. All you want to make sure is that what you have there is a layer at the bottom of the Q cup, so below the sample, and it's up to your discretion on whether that is needed to get the best analysis for you.
Excellent. What are the Mars 6 vessels made of?
Okay, real quick, we touched on that, but again, it's important to understand you have to basically make the vessels out of materials that are going to hold temperatures and pressures, be inert to acids, and allow the microwaves to pass through. And that's why manufacturers use Teflon, and then we use a Kevlar sleeve around it, and that gives it some strength, but also allows it to cool quicker. Teflon comes in two flavors. Primarily, it comes in lots more flavors, but mostly in digestion vessels, it comes in as PTFE and PFA. And for simplicity, we offer both. So you can work with either PTFE or PFA. There is some, around the world, some preferences, and we have both available, both of which use the Kevlar sleeve in order to provide the strength.
Excellent. What's the consumable cost per sample using the Edge prep system?
Okay. As far as the consumables are concerned, the only thing that is indeed a consumable is your Q-disc. And that costs you 75 cents per run. Now, the Q-cups themselves you wash those. So you can just drop those into a dishwasher or hand wash those. So that's not a consumable cost. If you were using sorbents, or in the solvent that you're using, but most likely you're already using that in your practice, right? So that would be added in, and I believe we actually do have a calculator on our website. You can actually put in your solvent volume and the sorbents you're using, and it'll give you kind of an idea of the cost per test there. But when it comes down to it, for me, the one that's not common to all the techniques is the Q-disc, which is eliminating that syringe filtration for you, and that's going to be about 75 cents per run.
Very good. What is the hand method for potency that you were referring to?
Okay. I'd have to go back to the labs to get exactly the details on the hand method. And I believe that Convergence Laboratories and Express Toxicology actually had slightly different hand methods. But when it's all said and done, it's pretty much taking the plant, the cannabis, your sample, and shaking it in solvent. And then typically they're doing some sort of cleanup, some SPE cleanup following that. So it's not a difficult method. I'm not trying to claim that the extraction for potency is a difficult extraction. However, pesticides is a little bit more challenging. So if you have one unit in which it can do everything for you, that really just makes the whole process efficient. But yes, the hand method is pretty straightforward in the fact that it is simply shaking in solvent.
Great. I've got a two-part question here. What besides contaminated soil is the source of heavy metals in cannabis plants? And how are metals transferred into cannabis oils during extractions procedures?
Basically, so that's a good question, and pretty much whoever asked the question, the soil is probably 98% of it, and that's just because whether it was used previously, if some industrial use, or just different pollutants got deposited on the land. That's really the issue there. Water is the other one, and that's why. What you're irrigating with. That's why some states actually do require a water test. And as far as the metals, when you do the digestion, what you're doing is, if we're answering the question correctly, is the idea behind is to destroy all the oils. So you've got to get in a clear digestion completely in order to be able to get trace metals analysis, and that's what we were doing with what the samples we were doing here.
Fantastic. Well, we're out of time, so we'll have to wrap up. Bob and Alicia, thank you so much for your talks today and for answering all those questions. I also want to thank everyone in the audience for attending and participating in our event today. And I'd like to thank our sponsor, CEM Corporation, for making today's webcast possible. If you had a question today that didn't get answered, someone will contact you after today's event. You will also receive an email alerting you when this webcast is available for replay. We invite you to forward that announcement to your colleagues who might have missed today's live event. We hope to see you all next time. Goodbye.